Assalamu alaikum everyone. How are you guys? Walaikum salam. My hello sir, as all your videos are for chemistry. Yeah, so you can cross-check the concepts and see if they're overlapping. Chances are that they will. Edexcel, I've gone through the Edexcel curriculum, and for the most part, it's the same. It's just that it's divided into many more categories. But yeah, for more or less, it's the same. I mean, you can learn the basic concepts through. You can learn the basic concepts either way. Back to normal routine. Not exactly. These are just for October, November students. Uh, so back in May, June, I was streaming almost every day. But this time around, I think I'll just do it twice or thrice a week. Let's see. Okay, so today, inshallah, we will do the remaining concepts as you can see over here. We will do increasing, decreasing function. We will do practical applications of nature and stationary value. Actually, not. No, actually, it's fine. Practical applications of nature of stationary value and rates of change. So these are the three main concepts which I plan on covering today, inshallah. So let's start with increasing and decreasing function. I've changed the order slightly. Actually, not the order slightly, the numbering slightly. But I will upload the updated document once we're done. Okay, so first let's go over increasing slash decreasing function. Okay. Sir, my school marks are before December. That would be a challenge. But P1, yes, you can. And mechanics with P1, that would be a challenge. Yeah, that would be a challenge. I mean, I hope you're able to, but it's a difficult task. Anyway, so as I was saying, increasing, decreasing function. Let's have a look at what an increasing function is, and let's have a look at what a decreasing function is. So we will understand this concept with the help of a quadratic curve. So let's say that we have ourselves a quadratic curve. Okay, any quadratic curve, in fact, for that matter. And there you go. In fact, you know what? I'm not even going to draw the y-axis, but yeah. So this is a quadratic curve. Okay. Now, this curve is basically doing three things. Okay. It's increasing, it's decreasing, and it is also stationary. Okay, at a particular point it's stationary, it's increasing, and it is decreasing. So let's say the point where it's stationary, we know that from before, it's this point right here. And why is it stationary at this point? The reason why it's stationary at this point is because if you were to make a tangent over here, you would get a horizontal line. So that's the reason why this curve is stationary. Now, what is the tangent going to be like if, let's say, I make it after h? Okay, let's say I make a tangent over here, and let's say I make a tangent over here. So here you can see that you have a line which is upward sloping. Okay, and just like that, if I make a tangent over here, okay, and I make a tangent over here, so here we have lines that are downward sloping. So this curve altogether can be divided into three categories. Okay, and I will highlight them. Here is the part that I'm highlighting in green. Okay, and here is the part that I'm highlighting in red. Now, this curve we know very well is stationary when x is equals to h. Okay, why? Because that is when the dy by dx, the gradient, is equal to 0. So this is stationary when x is equals to h. That means when dy by dx is equal to 0. Okay. Now what happens when x is greater than h, and what happens when x is lesser than h? Okay, let's start with x is greater than h. What do you think the gradient would be, and what do you think dy by dx would be when it is less than h? Question for you guys. when x is greater than h, is the function increasing or is the function decreasing? Yes, that is correct. So when the sorry about that. When x is greater than h, dy by dx is greater than 0. That means it's an increasing function. Okay. And when dy by dx is, when x is less than h, dy by dx is less than 0. That means it is a decreasing function. Okay. So remember, an increasing function basically means that the y values are increasing, which means that the gradient is positive. It's going to be greater than 0. And a decreasing function basically means that the y values are gradually decreasing and the gradient will be less than 0. Okay. Now, let's do an example to further understand this. So here's a simple example, and then we'll do some past paper questions along the way. So let's say you have f of x, which is equal to x square minus 8x plus 6. This is a quadratic curve. And the question says, find the range of values of x for which f of x is, and let's say there are two parts to it. Part A, increasing function, and part B, decreasing function. Okay, so let's say these are the two parts. Now, this is a fairly easy question. For an increasing function, remember dy by dx will be greater than 0, so that's what we're going to do. So f of x is like y, so that means y is equals to x square minus 8x plus 6, which means that dy by dx is going to be equal to 2x minus 8. For an increasing function, remember we set dy by dx to be greater than 0, so that means 2x minus 8 is greater than 0, which means 2x is greater than 8, which means x is greater than 4. Okay, this is what we do for an increasing function. For a decreasing function, we're going to do the exact same thing, except that we will do dy by dx to be less than 0. So that means dy by dx, which is equal to 2x minus 8. So 2x minus 8 is going to be less than 0, which means x is less than 4. So nothing different except for the sign that we use. I've already completed A levels and I got an A. Alright, good job, Imad. Happy for you. How hard is A level math? It is difficult. Okay. It is difficult, there is no denying that. But it has a lot of benefit. If you do well in A level math, a lot of things later on that you will do in university become easier. Now, there are three categories. By the way, I've uploaded this PDF in on. You'll find a link to it, which will take you to your Dropbox folder where you'll find this PDF. Now, I've highlighted the three types of questions that we will be doing. So here we have increasing, decreasing. Okay, so that's what we're going to do first. So let's do a few past paper questions of increasing and decreasing functions. So we'll start off with perhaps a relatively easier question. Okay, let's do this question. So it says here, a function f is defined for x is greater than half. Okay. And then it says such that f prime of x, so that means we already have the differentiated version. Okay, so you don't have to differentiate it to yourself, you already have it. And this, by the way, is from October-November 2019, paper 1, variant 3. Okay, so fairly recent, not that old. Then it says find the set of values of x for which f of x, for which f is decreasing. So the good thing about this question is that we already have the differentiated version. So that means we don't need to differentiate it ourselves. All we have to do is we just need to take dy by dx and equate it to less than 0. And that should solve our problem. Okay. So let's do just that and see what's what. Okay. So how will I differentiate this? In fact, it's already differentiated, so all I need to do is this. Take f prime of x and set it less than 0. F prime of x and set it less than 0. Okay. So we already have f prime of x, which means 3 into 2x minus 1 to the power half minus 6. And like I said, we're going to equate it to less than 0. Now let's see what happens next. If I solve it further, here is what we get. So we have 3 into 2x minus 1 to the power half, which is less than 6. Okay. And then take 3 across. So we have 2x minus 1 to the power half, which is less than 6 divided by 3 is equal to what? 6 divided by 3 is equals to 2. Okay. Now what do we do next? So how do we get rid of the square root? If we have square root on one side, how do we get rid of it? So in order to get rid of the square root, yep, we square both sides. So let's do that. Squaring both sides leads to 2x minus 1, which is less than 4. And now if we solve this, let's see what do we get. So we get 2x minus, in fact, 2x is less than 4 plus 1, which is 5, and x is less than 5 upon 2. Now notice the question said that we need to find the set of values. And what does that mean? Whenever the question says set of values, that means we're likely to get a range of answers, and that's exactly what's happened. Now, this is how we're going to solve this question. Now, take a good look at it, and let's do one more question before we do some. In fact, let's do some more practice questions. Okay, just 1 minute. Thank you, Hunan. Now, when you're giving your final answer, do keep one thing in mind, that the question here says x is greater than half. So when you're giving a final answer, make sure to write your answer in range form, because if you just leave it at x is less than 5 upon 2, that's incorrect. Why? Because there's already a range of x where it's greater than half. Okay. Anyway, so that was one question. Let's do some more practice questions before we move on to the next concept. Now, I have taken out some questions here. Let's do those. This is a concept that's not very frequently tested, so you won't find a lot of questions here. You won't find a lot of questions of this topic, but it's important nonetheless. Okay, so this is an example from the book. It's not from past papers. So it says here, for the function f of x is equals to 4x cubed minus 15x squared minus 72x minus 8. Find f prime of x, number 1. And then you need to find out the range of values for which it's increasing and for which it's decreasing. When will you do vectors? Vectors of what? P3? P3 vectors? Is that what you're talking about? So first of all, when we're doing part A, we'll differentiate it. So 4 into 3 is 12. So we have 12x squared minus 30x minus 72. And remember, an increasing function means that dy by dx will be greater than 0. Decreasing function means that it's going to be less than 0. So 12x squared minus 30x minus 72 greater than 0. What are we going to do? We're going to take 6 common if you can. So if you factor out 6, let's see what happens. So 12, in fact, let's do it over here. 2x square minus 5x, and 72 divided by 6, so that's 12 greater than 0. So we have 2x square minus 5x minus 12 is greater than 0. And now you can solve this through middle term breaking. I'm going to skip a few steps and just write the final answer. 12x squared, that is correct, Anas, good job. Okay, so if I skip a few steps and just write down the final answer, so we have 2 minus 5 and minus 12. So one value of x is equal to 4, and the other value of x is equal to minus 3 upon 2. Why are you a lefty? Yeah, I'm a left-handed. Yes. Okay. Now notice that we're not actually solving a quadratic equation. We're actually solving a quadratic inequality. And what we have found are actually two x-intercepts of a quadratic curve. Now in the first part, we need to write down the range where this curve is positive. Now where is this curve positive? Above the x-axis. Okay, so for part 2, this by the way was part 2 or part B? Yeah, part B. So for part B, the answer is going to be x is greater than 4, and in fact we use the word or rather, x is less than minus 3 upon 2. Okay, so that's the answer to part B. Why? Because we wanted the part of the curve for which x is greater than 0, or which basically means part of the curve where it's above the x-axis, so x is greater than 4 and x is less than minus 3 upon 2. Now for part C, where dy by dx is supposed to be less than 0, we're not going to do all the work all over again. In fact, we're just going to write down the range for this part of the curve, which is x is greater than minus 3 upon 2 and less than 4. And there you go. That's the answer. So like I said, this is not a very complicated concept and you won't find a lot of questions of it, sadly. But yeah, so that's that. Now the next concept that I'm about to do, that is quite complicated. Okay, and we will do that concept through example questions. Will I solve yearly? Let's see. If time allows, then yeah, I will. Towards the end, yes, I will try and solve a couple of yearly past papers as well. Okay. Towards the end, inshallah. Anyway, so I've taken out some questions here through which we're going to learn this concept called stationary value. Okay, it's practical applications of nature of stationary value. That is the concept that we're going to learn here. And this is perhaps the most complicated topic of differentiation. This along with rates of change. Okay. Now, questions like these you will notice follow a certain pattern and they will always follow that certain pattern only. So you will start off with a scenario where maybe you're given an object and you're given maybe the volume or surface area or something, and through that information you're asked to find something else. Okay, like for example over here it says here the surface area of the solid cuboid is 100 centimeters square and the volume is v centimeter cube. Okay, express h in terms of x. Now notice you're given some information, and through this information you will be asked to express one variable in terms of another. Now here you're given the volume, you're given the surface area of a cuboid. Now what is the surface area of a cuboid equal to? Let's see. So the total surface area of any cuboid, make sure you read the question carefully and see whether it's open, closed or whatever. So twice of length into breadth plus twice of length into height plus twice of breadth into height. Okay, this is how you find out the total surface area of any cuboid for that matter. Now you know what the total surface area is. You know that the total surface area is equal to 100. So 2 times x into x, so that's length into breadth, plus 2 times x into h, so that's length into height, plus 2 times x into h again. So that is also breadth into height. Okay. Now, let's simplify this. So we have 2x square plus 2hx plus 2hx, which is equal to 100. Now, these two can be added further. So we have 100, which is equal to 2x square plus 4hx. Now, is there something that I can take common? Yes, I can divide the entire equation by 2, and I'm going to do just that. I'm going to divide both sides by 2. So we have 50, which is equal to x square plus 2hx. Okay, now notice that what we're supposed to do over here is that we are supposed to, we're supposed to make h the subject. We're supposed to find h in terms of x. So that means 50 minus x squared is equals to 2hx, and we're almost there. 50 minus x squared is going to be equal to, let's see, 50 minus x squared upon 2x is what height is equal to. Okay, that's what we were supposed to do. And there you go. We have just done that. Okay. Now, so that's that. That's part A. This is what you can expect 9 out of 10 times a question to start like. Okay. Then we do part B. Part B says show that the volume is equals to. Now, these show questions are good in the sense that you can see what the answer is and you can be absolutely sure whether you've done it correctly or not. Okay. Now, the volume, if we were to take out the volume as it is, we would have done x into h. Okay. But because we now have h in terms of x, we are going to replace it with whatever expression we have formed. So that means v is equals to x square into 50 minus x square upon 2x. Now we cross out the square and we cross out the x. So now we have v is equals to 50x minus x cube upon 2. Okay. Then we're going to write it separately. So that means 50x upon 2 minus x cube upon 2. Now what is 50x upon 2? That's equal to 25x minus 1 upon 2 x cube. And there you go. That is your final answer. Okay. Now then comes the tricky part where it says it will always go like a certain value can vary, and you will be asked to determine whether this stationary value is a maximum or a minimum value. Now, how do we find out the stationary value of anything? You differentiate it and you equate it to 0. So in order to find out the stationary value of anything, whether it's volume, surface area, perimeter, you always differentiate it and you equate it to 0. So that's what we're going to do. In part C, we have v, which is equal to 25x minus half x cube. If you differentiate this, we get dv upon dx, which is equal to 25 minus 3 upon 2 x square. Okay. Now you equate it to 0. So that means 25 minus 3 upon 2 x square equals 0. So 25 is equals to 3 upon 2 x square. Cross multiply. So 50 is equals to 3x square, which means x square is equals to 50 upon 3. And then you can solve it. Okay. And if you solve this, this is what you get. X is equals to, although you get plus minus root 50 upon 3, but because x is a form of length, so it's going to be positive square root only. Okay, then it says and determine whether this stationary value is a maximum or a minimum. So how do you find out the nature of any stationary value? So for that, you have dv by dx, which is 25 minus 3 upon 2x square. Now you double differentiate it. D square v upon dx square is going to be 0 minus 4 upon 3. No, wait a minute. It's going to be 0 minus 6 upon 2x. Now this is equal to minus 3x. Now since x can only be positive, and when you plug in the positive value of x, so d square v upon dx square turns out to be less than 0, which means it is a maximum value. And there you go. That's the answer. Wa alaikum salam, Ibrahim. Okay. Angular waves. Isn't that a topic of physics? Okay, let's do a past paper question of this concept here, and then we'll do a past paper question of stationary value, of rates of change. Okay, let's try this question. How can we be a mod at your channel? So last year I just randomly selected moderators for the channel. Uh, if you're one of regular viewers, then you can also be a moderator. Okay, so it says here, this is a question from October-November 2019, paper 12. Okay, October-November 2019, paper 12. Remember that. And question number 5. So it says here, the diagram shows a solid cone which has a slant height of 15 centimeter and a vertical height of h centimeter. Okay, show that the volume v centimeter cube of the cone is given by so and so. Alright, so make sure that you guys remember the formulas for this. What is volume equal to of a cone? Volume is equals to 1 upon 3 pi r square h. Okay, that is what the volume is equal to. Now v is equals to 1 upon 3 pi. What is the radius? It's r. Okay, does it say that? Okay, no. And what's the height? It's h. Now notice that this is not what we're supposed to bring it equal to. Okay, we're supposed to bring it equal to something else. In fact, if you look at it, it's all in terms of r. So how do I bring it in terms of r? Let's see. So this is the radius and this is the height. In fact, let me draw it over here. There you go. Okay. Now what can I apply over here? I can apply Pythagoras theorem. R square plus s square equals to 15 square. Okay. And thankfully, I don't need to take the square root of r. I can simply do this. R square is equals to 225 minus h square, because now I can easily replace r square with 225 minus h square. So v is equals to 1 upon 3 pi 225 minus h square into h, and then when I simplify, this is what we get. Expand actually, not simplify. 225h minus h cube. And there you go. That's the answer. Okay, then comes part 2. Part 2 says, given that h can vary, find the value of h for which v has a stationary value. Determine, showing all necessary working, the nature of this stationary value. Okay, so how do we find out the stationary value? Like I said, you can expect a follow-up question where it's asking you to find out the stationary value. So we will differentiate this and we will do it with respect to h. So dv upon dh is equals to, now 1 upon 3 pi is a constant, so nothing's going to happen to that. All you got to do is differentiate 225h, which is going to be 225 minus 3h square. And this we're going to equate to 0. So 1 upon 3 pi into 225 minus 3h square equal to 0. Now if you cross multiply, 1 upon 3 pi it disappears, and now we have 225 minus 3h square equal to 0, which basically means that h square is equals to 225 upon 3. Now 225 upon 3 I believe is 75. So h square is equals to 75, which means h is equals to square root of 75. And yeah, there you go. That's the answer. Thank you, Ibrahim. And no, I don't teach angular waves. I think I didn't answer that question. Okay, then it says determine the nature of this stationary value. So how do we determine the nature of this stationary value? We have dv upon dh, which is equal to what? Which is equal to 1 upon 3 pi into 225 minus 3h square. Now we will double differentiate this, which means d square v upon dh square. So 1 upon 3 pi, remember, it just remains as it is. 225 becomes 0 minus 6h. Now, if you simplify this, this becomes minus 2 pi h. Now, irrespective of whatever you plug in place of h, since h is always going to be positive, so that means the overall result will turn out to be negative. And if d square v upon dh square is less than 0, that means it's a maximum value. And there you go. That's the answer. Okay, now let's do a question of rates of change. Okay. We will, in fact, let's write down the notes for rates of change, and then we'll do a question. And then maybe we'll do a detailed live stream solving all questions of differentiation. Okay, so what exactly is rates of change? What is the purpose of it? So it basically allows you to find the rate of change of one variable with the help of rate of change of another. That's what it does, in short. Okay. Now, there are a couple of rules to remember. Whenever the question says rate of change of, let's say, radius with respect to time, or even if it leaves it at rate of change of radius, that basically means it is telling us dr upon dt. Okay, that means the change in radius represented by dr with respect to time represented by dt. If, let's say, the question says the rate of change of volume with respect to time, what does that mean? That means dv upon dt. Okay, so this means dv upon dt. If, let's say, the question says rate of change of, let's say, height with respect to time, what does that mean? That means dh upon dt. If, let's say, the question says rate of change of area with respect to time, or like I said, even if it leaves it at rate of change of area, then it's going to be dA upon dt. Okay. Now, in this question, we will do something called chain rule. Okay. Now, chain rule is something that we will have to form in order to get to the final answer. Now, how do we do that? Let's do a question and see what's what. Okay. So I will just do a rates of change of question, and that will be it. Today's stream is not too extended. Okay, we will have another stream where maybe we can cover, where maybe we can do all the questions, all differentiation questions. Okay. So yeah, just hang in there. Okay, let's do this question here. All right. So this question here says the volume V meter cube of a larger circular mound of iron ore of radius R. And this, by the way, is from October November 2021, paper 2, variant 1. Okay, October November 2021, paper 12. Sorry, yeah, paper 12, question number 9. Okay, let's see what it says. So it says here the volume V meter cube of a large circular mound of iron ore of radius R meter is modeled by the equation so and so. Okay, then it says iron ore is added to the mound at a constant rate of 1.5 meter cube per second. Now notice, what is this 1.5 meter cube per second? This is basically, what do we measure in meter cube? Volume. So that means this is dV upon dt, which is equal to what? Which is equal to 1.5. Okay. Now let's see what's next. Then it says find the rate of change of radius. Now, rate at which the radius is increasing at the instant when the radius is 5.5. So it's asking us the rate at which the radius is increasing. That means the question is asking us to find out the rate of change of radius with respect to time. And when does it want to do that? When does it want us to do that? It wants us to do that when radius is equals to 5.5. Okay, so this is how nearly all the questions will be structured. So here's what we are going to do. First of all, what we're going to do is we're going to make something called the chain rule. Okay. Now, how do we make the chain rule? There's a standard way of doing so. That is, you write down what you want, which is dr upon dt. Now, this will come as a result of multiplying two fractions. Okay, this will come as a result of multiplying two fractions. The numerator of that fraction is going to be dr. The denominator of that fraction is going to be dt. Okay, same as this one, and this is going to be same as this one. Now, in both these places, we will have something that is common. Okay, and it also has to be relevant, in the sense we can't have, like, for example, x over here. X is not relevant in the question. So what's common as and also relevant? What's common and relevant in this is dv. So that means here and here we will have dv. Okay, so in these two places we will have something that is common and relevant. Okay, now let's see. So we have dr upon dv. In fact, we don't have dr upon dv. We have dv upon dt. We can find out dr upon dv. How so? By differentiating volume with respect to r. So 3 upon 2 r minus 1 upon 2 cubed. Now if I differentiate this, this is what I get. dv upon dr, 3 into 3 is 9. 9 upon 2 into r minus 1 upon 2, the whole thing square. Okay, is the answer 1 upon 75? I don't know. Let's find out. The whole thing square. Now we need to find out a value of dv upon dr, and for which we're going to plug in the value of r, which I believe was 5.5. Yeah. So 9 upon 2. Now if you plug in 5.5 in place of r, so 5.5 minus 0.5 is going to be just 5. Don't forget to square it. So 9 divided by 2 into 25, so that's equal to 112.5. So dv upon dr is equals to 112.5. Now, if dv upon dr is equals to 112.5, now we have 1 upon 112.5, that is dr upon dv. Now, why have I taken the reciprocal of it? Because in the chain rule, we were supposed to take dr upon dv. Multiplied by dv upon dt, which is something that was already given to us. That means multiplied by 1.5. Now let's see what do we get. So 1 divided by 112.5 into 1.5, so that gives us 1 upon 75. So you're right, the answer is in fact 1 upon 75. There you go. Okay, there is a follow-up part to it as well. Let's see what that is. The follow-up part is find the volume of the mound at the instant when the radius is increasing at a rate of 0.1 meter per second. So that means now we're given dr upon dt, which is 0.1 meter. And what do we need to find out? We need to find out dv upon dt, because that's what the question says. Find the volume. In fact, wait a minute. The question is asking us to actually find out the volume. So we need to find out the volume. Okay. Now, how are we going to do this? Let's see. Hi sir, should I reset in October, November if I... I got a D of. Remember, you can improve it by 2 grades maximum. Okay, so if your objective is to get an A, then I will not recommend it. But if you want to settle for a B, then yes. Because in my experience, you're only able to improve your grade. You're only able to improve 1 grade per month. So if you're at a D and you only have technically the month of September, so you might be able to bring it up to a C or maximum a B, but not up to an A. Okay, so coming back to the question. So we'll do this question and then we'll stop and then maybe we'll do another live stream where we will do a collection of past paper questions. Okay. So it says here, find the volume of the mound at the instant when the radius is increasing at a rate of 0.1 meter per second. Okay. Now, so when dr upon dt is equals to 0.1, so what we can do is this. We can actually use this to find out dv upon dr. How? Let's see. So if you go back to the question, this is actually more of a integration question, but we can still do it. Let's see. So dr, let's say we want to find out dv upon dr. How can we do that? Here we'll have dv and here we will have dr. Okay. So in both these places, we will have something that's common. Okay, and it also should be relative to the question. So that means we can have dt over here and we can have dt over here. Now dv upon dt is something that was given to us in the question. Okay, dv upon dt basically means the rate of change of volume, which is 1.5. So we write 1.5 over here. And dr upon dt is 0.1. That means dt upon dr will be 1 upon 0.1. Okay, now if you work this out, let's see what we get. 1.5 into 1 divided by 0.1. So that's equal to 15. So that means dv upon dr is equal to 50. Now the question is, why did we do this? Why did we find out dv upon dr? So for that, if you go back to the question, notice we need to find out so the journey is this. If you want to find out the volume, okay, you can't find out the volume even though you have the formula for volume, which is 3 upon 2 into r minus 1 upon 2 cubed. But before you can find out the volume, you need to know what r is equal to. And if you need to know what r is equal to, you need to know what dv upon dr is equal to, which we do now. We know that dv upon dr is equals to 15. That means that this expression is equal to 15. So this expression right here is equal to 15. And with the help of this, we will find out the value of r. So r minus 1 upon 2, the whole thing square. 15 gets multiplied by 2, divided by 9. So that's equal to 10 upon 3. Okay, I think we have a question here. And then we take the square root on both sides. So if you take the square root on both sides, so r minus 1 upon 2, remember to only take the positive square root of 10 upon 3. Can we do test paper stream? What do you mean by that, test paper stream? R is equals to plus square root of 10 upon 3 plus half. Now that we know what R is, we will plug in the value of V. We will plug it in V to find out the volume. So 3 upon 2, R gets replaced by positive square root of 10 upon 3. If you keep it in exact terms, things will cancel out. And then we're going to cube it. Okay, so this half and this half gets cancelled out. V is equals to 3 upon 2 into 10 upon 3 inside the square root, the whole thing cubed. Now, work this out using a calculator. And if you do it correctly, let's see what you end up with. So first of all, 10 divided by 3. And then let's take the square root of it. Then let's cube it. And then multiply it by 3 divided by 2. So we end up with 8.13. Volume is equals to 8.13. And there you go. That's the answer. Now, what's your question? Yeah, which is why I will not recommend that you give it in October, November. I will suggest that you give it in May, June, which are quite important since we didn't do media practical. Okay. So, if you want to pursue a field in which math is really not that important, then why are you giving a retake to begin with? Hello, sir. Will you be solving O level papers this month? I don't think. Maybe I will. I don't think there are a lot of students who are giving O level exams, but maybe I will. Close to the exams, I will. O level math and ad maths. I do plan on streaming for O level maths and ad maths, and of course IGCSE. But whether I will solve papers or not, that will decide. Okay. Anyway, so isn't the answer 9.13? Is it? Let me check. 3 upon 2 into square root. You're right, it is 9.13. My bad. Let me check what the correct answer is. Just a minute. So this is October, November 2021, paper 12. Okay, so yeah, that's it. Sir, it's mostly because I want a good grade and I know I can get one. I mean, I have 3 other subjects as well. Okay, so first thing that I think you should do is you should see where you want to apply to, as in the university, and see what the requirement is. And see if you get like an extra edge by getting a good grade in maths. If that is the case, then yes, improve your grade. If not, then not suggested. Okay. Then it's best that you improve the subjects that you plan on pursuing later on, which have a requirement, uh, which are required in the university you want to apply to. Okay. But do your research. That's very important. A lot of students, they do study subjects they like, but when they apply for a university, they realize that the requirements are something else. So that is why it's important that you do your research and then see what it is that falls in your domain, okay, or what subject you should take in order to pursue what you want. All right, so I'm going to stop here. All right, we'll have another stream inshallah where we will solve lots of past paper questions. Okay, but for now this is enough, and I will see you guys soon. Let me know what stream you guys